What if I told you that everything around you, the chair you're sitting on, the air you're breathing, and even you, are all made of the same fundamental building blocks? It sounds like something out of a sci-fi movie, but it's a concept that thinkers have been wrestling with for over 2,000 years. Today, we're going on an epic journey to unravel the story of the atom, from an ancient philosophical idea to the cornerstone of modern science. Our story begins around 400 BC in ancient Greece, with a philosopher named Democritus. While his peers were debating the nature of the elements earth, air, fire, and water, Democritus proposed something truly radical. He imagined cutting a piece of matter in half, again and again. Eventually, he reasoned, you'd reach a point where you couldn't cut it any further. He called this final uncuttable particle atomos, which literally means indivisible, for Democritus. These atoms were solid, eternal, and infinite in number, constantly moving and colliding in an empty void to form everything we see. It was a brilliant idea, but without any way to prove it. It remained just that a philosophical thought experiment. It's largely overshadowed by the ideas of Aristotle for the next 2 millennia. Fast forward over 2,000 years to the early 1800s, the world is in the midst of the Industrial Revolution, and science is becoming a field of rigorous experimentation. An English schoolteacher named John Dalton dusted off Democritus's ancient idea and gave it a scientific makeover. Dalton noticed that chemical substances always combined in fixed whole number ratios. For example, water was always made of the same proportions of hydrogen and oxygen. He proposed that this was because all matter was made of tiny, indivisible atoms. Each element, he said, had its own unique type of atom with a specific mass, and chemical reactions were simply the rearrangement of these atoms. Dalton's atomic theory wasn't just philosophy. It was a powerful tool that could explain and predict chemical behavior, laying the foundation for modern chemistry. For nearly a century, the atom was thought to be a solid, indivisible sphere, just as Dalton imagined. But in 1897, the British physicist J.J. Thomson was experimenting with cathode-rays mysterious beams that appeared in vacuum tubes. He discovered that these rays were made of particles much smaller than any known atom, and they carried a negative electrical charge. He had discovered the electron. This shattered the idea of the indivisible atom. If atoms contained these tiny negative particles, they couldn't be solid spheres. Thomson proposed a new model, often called the plum pudding model. He pictured the atom as a sphere of positive charge with negatively charged electrons embedded within it, like plums in a pudding. The atom was no longer indivisible, but the story doesn't end there. A few years later, one of Thomson's former students, Ernest Rutherford, decided to test the plum pudding model. In 1911, he conducted a groundbreaking experiment, fired tiny, positively charged alpha particles at a very thin sheet of gold foil. According to the plum pudding model, these particles should have passed right through with only minor deflections, and most of them did. But to Rutherford's astonishment, a tiny fraction, about 1 in 8,000, bounced right back. He later described it as being as surprising as if you had fired a 15-inch shell at a piece of tissue paper and it came back and hit you. This could only mean one thing. The atom's positive charge was unspread out like a pudding. Instead, it must be concentrated in an incredibly small, dense center, which he called the nucleus. The electrons, he proposed, must be orbiting this nucleus, like planets around the sun. The atom was now seen as mostly empty space. The journey of the atom is a perfect example of how science works. It's a story of curiosity, brilliant ideas, and the courage to challenge old beliefs with new evidence. From a simple philosophical question to complex quantum mechanics, our understanding has evolved dramatically. What started as atomos, the uncuttable, has been cut again and again, revealing a whole new universe inside. What do you think is the next big discovery waiting for us inside the atom? Let me know in the comments below. Thanks for watching, and don't forget to like and subscribe for more journeys into the world of science.